Hello everyone. Now let's discuss another point, that is induction motor act as a transformer. As we know that induction motor is nothing but the rotating transformer, as we have discussed earlier. We can call induction motor as a rotating transformer. Why? Because for transformer we know that we have the two windings, primary and secondary winding, which are electromagnetically coupled to each other. When we give supply to the primary, or primary is connected to the AC supply, then it induces EMF in secondary winding due to the principle of mutual induction or self induction. Same in induction motor operate on the same principle of induction, because the stator winding is connected to the three phase AC voltage, and AC voltage is induced in a rotor winding, as shown in figure. Okay, here we can see that two transformer, primary and secondary winding is here. Primary producing flux, these flux are linking with the secondary winding due to the air gap. This primary stator wind, same we can call the transformer as a rotating transformer, with a stator with the primary winding and the rotor of the secondary winding. Due to the induction principle also, the voltage is induced in the rotor winding, so we can call it as a induction motor as a rotating transformer, right? We know that let's E1 be nothing but the EMF per phase, and E2 be the rotor EMF per phase at standstill condition. Okay, just let's see. E was nothing but the EMF, rotor EMF at standstill, and E2 is nothing but the rotor EMF at the running condition or standstill condition. Then we have the transformer ratio of E2 by E1 is equal to N2 by N1 is equal to K, which is nothing but our transformation ratio. Okay, according to that same, for this we can also derive the transformation ratio of E2 by E1 is nothing but the rotor EMF per phase divided by stator EMF per phase. We can have this EMF equation, okay, where N2 is nothing but the rotor EMF, rotor turns per phase, and N1 is nothing but the stator turns per phase. Okay, this is what for the induction motor as a rotating transformer. Now let's see what are the similarities and difference between the induction motor and the transformer. Okay, just wait, we'll discuss, and further we'll discuss the equivalent circuit of the induction motor. See, for transformer the core flux are alternating in nature. That means whatever the flux produced by the primary winding are alternating nature. For induction motor, the air gap flux are rotating, because the flux are produced by the three phases, so the fluxes are there in a rotating nature. Here in case of the single phase transformer, only one flux is produced, so is a alternating nature. For induction motor is of the rotating nature. The frequency of primary and secondary voltage for the transformer is same, but for the as we know, because transformer, the primary and secondary voltage having the same frequency, because the transformer does not change the frequency. But in case of the induction motor, the rotor frequency of rotor induced EMF is not same for the stator voltage, it changes with respect to the slip, and the rotor frequency of rotor induced EMF is given by the slip times the stator frequency. Now next difference is for the transformer, the secondary voltage is constant once the primary and secondary winding turns are decided. But for the induction motor, the rotor's induced voltage is also depend upon the slip, as like the frequencies depend upon the slip. The rotor induced voltage of induction motor also depend upon the slip. The rotor induced voltage of induction motor is given by the slip times the rotor primary voltage, or the slip times the rotor induced voltage at standstill conditions. Okay, so this is what for the induction motor. Difference between the induction motor and the transformer. Now let's discuss the next point, that is the equivalent circuit of induction motor. So here we have the basic equivalent circuit of induction motor. Okay, as we have discussed earlier that the induction motor is nothing but equivalent to the rotating transformer. Hence with the help of that we can by taking the transformer equivalent circuit, we can draw the equivalent circuit of induction motor. See, the figure shows a basic equivalent circuit diagram of induction motor, which is similar to the equivalent circuit of the transformer. Here R1 and X1 are nothing but the stator resistance and the stator leakage reactance respectively. Hence E1 is nothing but the per phase stator voltage, N1 stator number of turns into second stator rotor number of turns. R2 and X2 are the rotor resistance and the rotor reactance per phase respectively. Here one more thing you have to get notice about this, that this R0 and X0, these R0 and X0 are nothing but the no load resistance per phase, that which represent the core loss component of equivalent circuit, and X0 is nothing but the magnetizing component of no load stator current, which are nothing but similar to the magnetizing current component of induction transformer at no load primary current, as we are discussing the equivalent circuit of induction motor. Okay, then see, this is what E1 and E2 are the primary and secondary voltage are the respectively, right? Let's say V1 is nothing but the stator supply voltage, see, all these equivalent circuit are important to know to solve some complicated equations and some numericals by finding efficiency and regulation by using this equivalent circuit. We will transfer equivalent circuit to primary and equivalent circuit to secondary also, for to examine its characteristics. See, as you know that the rotor current is given by the rotor current is equal to SE2 divided by impedance. It indicates that the rotary equivalent circuit can show the fixed value of reactance and the variable reactance for the R2 by X. That means for as the sleep changes, the value of equivalent circuit component also goes on changing.